Faisal, as I said, is our staff technical support engineer from Palo Alto Networks, who will be giving us this information on Prisma SD-WAN. And Faisal, are you there, sir?
Yeah, hi. Good morning, good
With
afternoon.
that, I'm going to take it over and let you take over. Have a good one.
Good morning, good afternoon, good evening, everyone. Thanks for joining this session. Today's session is focused on Prisma SD-WAN branch side operations and troubleshooting. It's a foundational course which gives you an introduction to Prisma SD-WAN for operating a branch and the various components that are involved in setting up a branch site. Okay, before let me share my screen. Charles, can you help me to share my screen?
All right. Is it just not? Oh, I'm sorry. Yeah. I did forget to stop sharing myself. I apologize. There you go.
Yeah, sure. Okay. Okay, so do you see my screen?
Not yet. Oh, it's coming up. Yep, there you go now. We see it now.
Yeah. Okay, so this is the agenda for today. The session is split into two sessions, right? Today and tomorrow. Today is focused more on the Prisma SD-WAN branch side operations, and we will do a session 2 tomorrow for focus on troubleshooting. So here we'll try to build the knowledge of the user, of the participants, to understand the various components of Prisma SD-WAN and how they work together, and then we will try to apply them in the day 2 to utilize those tools available for troubleshooting. So as I said, this is a foundational course primarily intended for somebody who has started with Prisma SD-WAN, and also for those who have been using Prisma SD-WAN in the legacy portal to understand how to use the new Starter Cloud Manager for the Prisma SD-WAN application. Okay, so the agenda for today is to have an overview of the Prisma SD-WAN. After that, we have the cloud controller, which is a core component of Prisma SD-WAN. An overview of the Starter Cloud Manager portal with respect to Prisma SD-WAN. Prisma SD-WAN sites. What are the sites available in Prisma SD-WAN? The devices, zero-touch provisioning for the ION device, interfaces, the different types of interfaces available in Prisma SD-WAN, circuit labels, the different overlays, namely the secure fabric and the service link for third-party VPNs, the unified app ID, branch routing, static and BGP, branch services. We focus on three of them: DHCP, SNMP, and syslog. Policies, path, QoS, and NAT. So just to remind you again, this is a foundational training. We focus on defining these components of Prisma SD-WAN. Each of these topics can delve into a different session altogether. So here, when we discuss about the policies, we are going to discuss about the default policies available in Prisma SD-WAN for a user to start using a Prisma SD-WAN branch site, and then based on and how these blocks have been by default created, and how to use them to create your new branch site. And that's it. So this is the agenda for day 1, and this is more about operating a Prisma SD-WAN branch site. So Prisma SD-WAN overview. So the Prisma SD-WAN comprises of a cloud controller, which manages your infrastructure for both branch site as well as the data center. So all the ION devices are connected to this controller through a long-lived TLS connection, and all the configuration is stored in this controller. So what happens is when the device comes online in your portal, it connects to this cloud controller and then synchronizes the configuration. So at any given time, the Prisma SD-WAN controller is a source of truth. You don't need to worry about backing up these devices. You don't need to worry about restoring the configuration. Whatever stays on the portal gets applied on the remote offices ION as well as the data center ION. So if you take a branch site, you basically have transports, different WAN transports, and then you have overlays on top of these transports, which provide secure connectivity to your data center. So all these things are managed through this cloud controller. We will go in detail and see how these things are created and how it works together, and how you can use the Prisma SD-WAN platform to forward your traffic towards the direct internet, as well as to the overlay connections for both secure internet as well as your private apps to the data center. The next generation SD-WAN, Prisma SD-WAN, is a cloud-delivered service. We do have an on-prem controller as well, but this session is purely focused on the cloud controller. We have app-defined autonomous SD-WAN to securely connect your branch offices and data center while minimizing cost and complexity. How we can achieve that, we will be showing you in the session today. Prisma SD-WAN is a key component of the SASE framework, along with Prisma Access. Prisma SD-WAN ensures the modern enterprise can achieve secure and high-performance connectivity. Application performance engine which powers the software-defined WAN solution, transforming traditional WANs into simplified, secure, app-driven fabric. It virtualized the diverse underlying transport, whether it is an LTE, whether it's a broadband, whether it's an Ethernet, internet, whether it's a leased line, whether it's microwave-based connectivity. It kind of removes the complexity of these transports, including PPOE, and then creates a unified WAN, which is managed through your Prisma SD-WAN portal. Some of the key terminologies with Prisma SD-WAN, it is unique to this platform, which is very essential to know so that you can understand, as I explained in the slides to follow, what do exactly these terminology refer to or mean. So ION stands for Instant On Network. This is the CPE component that sits on the remote side as well as the data center. It comes in two form factors, virtual as well as physical. The app fabric, the app fabric is the overlay VPN, which gets built automatically by the controller between the ION devices for the branch with the data center and between the branches. MIC, which stands for Manufacturer Installed Certificate. By default, when an ION is shipped to you, it contains the certificate. KIC stands for Customer Installed Certificate. This is a certificate which gets installed when you claim the device. TPM is a tamper-proof module for securing your device, ION device. HA stands for High Availability. Fail to wire is our trademark feature, which uses a concept called bypass pair on your interface ports, where you can utilize 100% of your WAN circuits in a branch, in a Prisma SD-WAN branch. So then claiming a device. So as far as when you connect a Prisma SD-WAN ION to the controller, there is a process of claiming where you accept the device into your tenant and start utilizing the Strata Cloud Manager to configure this device and assign to a site and start using it for your branch. The scope of an interface. So scope of an interface can be either global or local. So local means the prefixes attached to this interface will not be published across your fabric. Global is to indicate any other branch site which would like to connect to this address prefix. It will be published into the app fabric, and they will try to connect over it. We'll see when we go across this, when you go into the slides related to interface. The control mode, the Prisma SD-WAN comes has three control modes: disable, analytics, and control. So this defines how a branch will function. So by default, it's in disable state, and then you can make it into control so that it participates in your infrastructure. So monitor analytics mode. LQM is the link quality monitoring, which is used to measure your WAN paths and overlay WAN paths. Bandwidth monitoring is to determine how much is the capacity of your circuit. BFD is a bidirectional forward detection used to determine VPN liveliness, and the NPL is underlay reachability. The BGP peer comes of three types are mainly classic peer, core peer, and edge peer. Today's session, we are going to talk about Prisma SD-WAN branch side, so we'll be discussing mainly about the classic peer. The core peer and edge peer applies to the data center ION. Okay, so this slide explains to you lists down the Prisma SD-WAN components. These are like Lego blocks, So you have these components which connect together and can really take you from a simple branch site to a very complex branch site. So understanding of these components, these micro components, these components related to Prisma SD-WAN is very essential. So it kind of lays the foundation for the platform. The cloud controller, Strata Cloud Manager portal, the sites, branch or data center, devices, zero trust provisioning, interfaces, circuit tables, VPN, secure fabric link and service link, branch routing for BGP or static. And in the new version, we do support OSPF, but for today's session, we are going to discuss about BGP or static, policies, path, QoS, NAT, and security, endpoints, domains, and groups. So these are kind of components which are part of Prisma SD-WAN, which work together and which are kind of essential components required to build your Prisma SD-WAN branch. So the cloud controller. SD-WAN cloud controller comes with 3 global regions, compute regions. So Americas, EMEA, APAC. So in America, we have 2 controller regions, El Capitan and Hood. We have Sugarloaf, we have for EMEA and Buffalo, and for APAC, it is Townsend and Faber. Based on the time of onboarding of a Prisma SD-WAN tenant, you get attached to the nearest region of your controller. It is and then it is the source of truth for Prisma SD-WAN. All the config stays on the controller, and we don't. We have a cloud-based controller which is managed by Palo Alto Networks, and the config, everything, all the devices connect to it and synchronize for the branch as well as for the DC IO. The cloud-first approach with cloud high availability, elasticity, and auto scaling. So there's no hard-defined limits as such, but as you grow, the cloud controller will be able to handle as many number of branch sites you connect. The service isolation per tenant, so the tenants are isolated, even though they're part of the same cloud controller. They're all specific to each customer, and you don't see the other tenants unless you fall under a set of abstraction called MSP, where you will be as an MSSP partner managing all your customers through a centralized portal. So you have a separate Strata cloud manager for that. But here, as far as an individual customer is concerned, individual customer has his own tenant with all his devices. API first strategy and architecture. So this is the strength of Prisma SD-WAN, where you can use APIs to onboard large number of IoT devices, large number of sites, push all the different types of configuration. We are RESTful first API, and you can, and if you are aware of the automation, how to do it, you can build a very large network at a very short time. So this is how the SD-WAN UI, the controller connects to the ION devices on site. We have a portal where the user can go and monitor the status of the region, whether it's operational, whether there's an ongoing maintenance. And even when there's an ongoing maintenance going on, it's more about accessing the portal. It's not about the data plane. So the data plane traffic is not disrupted. The access to the portal will not be available. Any APIs will not work during that instance of maintenance. So we have a link called SASE status, paloaltonetworks.com, where you can go and you can subscribe to it. You can see the operational status of the controller, and you can see the upcoming events. So according to your region, you can be aware that these are the activities going on. So currently, all the Prisma SD-WAN controllers are operational, they're online, they're functional. But then there's an activity, it will be published over here in the calendar, and you can take steps and inform your SOC that the portal won't be accessible, but that won't impact any of your data traffic. Now, how to identify the controller region for a tenant from SD-WAN, Prisma SD-WAN SCM portal? Does anybody know? If you are aware, you can type it on the chat. Okay, so the Prisma SD-WAN controller, which region to which a tenant is connected to, can be determined from the dashboard. So in the dashboard, we have the controller region defined. So here, this particular dashboard says that the controller region is Faber, And this way you can identify which controller you're connected to, controller region you're connected to, and just take note of the maintenance activity happening on that specific region, not necessarily all the regions, because the maintenance happens over a number of days. And so you just need to be aware of what your region is. You can determine it from the dashboard, Prisma SD-WAN, device to controller connectivity. The controller region is in the right corner. You can also find it out from the device toolkit of the ION, where there's a command called dump overview, which indicates to you where the controller, which controller you're connecting that ION device to, what is their IP addresses, where the stats and flows are connected. So these are the two primary ways of determining which region your tenant is connected to. Okay. So if you go, yeah, first of all, in order to access the Strata Cloud Manager, we have the apps portal, apps.paloaltonetworks.com/app. You have the Strata Cloud Manager. Once you click on it, it does your SAML web authentication, and then once you authenticate it, this is the page you land into. So Charles, you're able to see the screen, right? Yeah, is it clear?
Yeah, we're good.
Yeah, good. Okay. So with regards to the SCM platform, this is the dashboard. This is the landing page where you'll see the command center. From the dashboard, we have the Prisma SD-WAN tab, and over here you see the controller region as Faber. And these are the number of devices connected to. Okay, and with regards to the device toolkit, I just have a screenshot here where you can see that this particular device is connected to the Faber region. Okay. So let's get back to the slides. The SCM portal. So SCM portal is the central management platform for the Prisma SD-WAN. It not only powers your Prisma SD-WAN, it's not only used to manage your Prisma SD-WAN, it is used to manage your Prisma SASE, which includes Prisma Access as well as SD-WAN, next gen firewall, and it is a unified platform. And we will today focus on the Prisma SD-WAN portion of the menu of the Strata Cloud Manager, which is applicable to, which you need to operate and manage your Prisma SD-WAN infrastructure. The Strata Cloud Manager can easily manage and monitor the Prisma SD-WAN infrastructure. The users are authenticated to the SCM via SAML integration. The key components of the Strata Cloud Manager are administrative interface. So this is the central location from which you create your configuration, manage your configuration, monitor your configuration, and communicate with your infrastructure, Prisma SD-WAN infrastructure. The dashboard, incident and alert, monitor, manage, workflow. These are the menus in Prisma SD-WAN Strata Cloud Manager, ION device management, and software update. So today we are just going to have a kind of introduction into these different pages, these different parts of Strata Cloud Manager. Tomorrow we will go deeper into this incident and alerts, monitor, and dashboard, which is primarily how to use these pages, these features in the Strata Cloud Manager to aid you in your troubleshooting. So this is the dashboard, and you can access it from the Strata Cloud Manager dashboard. So this is a small dashboard icon over here. Once you click it, you select on Prisma SD-WAN. You see a lot of widgets over here, device to controller connectivity. So it gives you an overview of all your devices which are online and offline, the application traffic, any major incident, and many other widgets over here. The next one is the incident and alert. Incidents, issues happening on your SD-WAN branch side. Alerts are something which is critical, which you need to pay attention to. So here in the Prisma SD-WAN incident and alerts, we see it kind of summarizes all the issues for all the branch sites, and this is an overview, and then we have other two tabs for incident and alert. So here you have an icon here over here in the Strata Cloud Manager, from which you can access the incident and alert portal. We have Prisma Access as well as Prisma SD-WAN. We need to go into the Prisma SD-WAN menu to see the SD-WAN related incidents and alert. The next one is the monitor, which is used monitoring all your branch sites which are connected to your tenant. So we can access the monitor from the Strata Cloud Manager, monitor, and then branch sites. So under branch sites, we have Prisma SD-WAN. Under Prisma SD-WAN, we have map, which gives you a geolocation of all your branches, list, which lists out all your branch sites. Activity is to give you an overview of what's going on in those branch site, and then the flows. The policy, and okay, so that one is the manage page in the Strata Cloud Manager, where you manage your bindings, your path policy, security, QoS, NAT, everything. So this is more about configuring the central components of Prisma SD-WAN, which applies to all your sites. Monitor is for monitoring your branch sites, and then the way you set up your configuration is the next one, which is the workflow. So this is the workflow menu. So over here, you will configure your SD-WAN branch sites, devices, you clean your devices, you assign your devices, all those activities is performed here. ION software upgrade is also performed from here. It's performed from the menu, Strata Cloud Manager, workflow, device, clean device, and upgrade. This is the portal. This is how it looks like. You can select the version of software you need to install on the device. Okay, so I have a quick demo. As I mentioned to you.
Hey, Faisal, quick question. One of the guys was asking in the chat is what version of the controller? It looked like it was a version 5.6. You could upgrade to 6.1 or something, correct?
Yeah, the controller version is managed by is the same for everyone. We don't. It's managed by Palo Alto Networks, and and the thing is the one I showed you just now is for installing on the ION device. Okay, so this is the new portal called Strata Cloud Manager, and the controller itself is upgraded and managed by Palo Alto Networks, and it is the same for everyone. Okay. The specific version we can get the version for Johnny. Okay.
Cool. Thank you much.
Okay. So this is the SCM portal. So I'll just run through the screenshots I just shared. So over here we have a settings menu. We have the dashboard. So the dashboard we have SASE Health as well as the Prisma SD-WAN. Under Prisma SD-WAN, we have a time range available for you to define 1 hour, 3 hours, 24 hours, and 7 days. So according to the time range you select, it would summarize the widgets over here. So this one is the most important one, which refers to the number of devices which are online for branch, number of devices which are online for data center. And one good feature about this is if you click on the offline devices or the online devices, it will go and show you under the devices in workflow menu the devices which are connected. All right. So here we have the dashboard. This one is SD-WAN. The key takeaways that gives you a footprint of what's happening in your network. It gives you what's online, what's offline, what region you're connected to, what apps you're using, any major incidents in the branch or data center, the bandwidth utilization, overall bandwidth utilization, and the transaction stats. The next one is the incident and alert, Prisma SD-WAN. So over here, if you see, this is a summary page, what's happening in your network. So this lists down to you the warning, there's an information, there are 0 critical alerts. So based on what you see here, there's a classification of the alerts P1, P2, P3, P4. You can click on it and see what's going on with this incident. So this particular incident is a config mismatch where the circuit is being not defined on the interface. So this is more of a config issue. This is just an incident, not an alert. So alerts are listed under here. So there was a process restart, there was a device reboot, and then if you click on it, so it tells you what is the severity of this alert. what is the fault code, what is the correlation ID, when did it happen, when it got updated, what is the entity which got impacted, and some of the remediation playbooks which you can quickly use to do some basic troubleshooting, which site it belongs, which site this particular alert was generated for, which device, ION device within the site where this alert was generated. Okay, the next one is the monitor branch sites. Under monitor branch sites, we have Prisma SD-WAN. So as I mentioned to you, we have a map which gives you so when I click on it, it quickly locates in the map where these branches are located. So and then if you click on this, it shows me this is branch 1, this is branch 2, and from here you can navigate and go inside the branch site summary page. So another good feature about this map menu is if you click on the branch, right, you can go and see what incidents are happening there, what is the status of your VPN, what is the physical connectivity of your WAN circuit, what is the state, if there's any standard VPN which are connected. So it kind of gives you a footprint of what's going on within the branch site, a quick summary. Okay, and later if you go inside the list, you can see the branch site over here. You can click on it, and then it will land you into the site summary page, which gives you an overview of your overall health, your circuits, your application, your flows specific to this branch, and then your incidents and alerts. Now, when we saw the incidents and alert from here in SCM, we were seeing it across the different branch sites. It was not specific to an individual branch, but this one over here is specific to this particular branch site, SASE BR01, and here you have different time ranges available across this time. You can select this time range, and you also have a start date to define. According to the start date, you can see what was happening in your network for this particular branch during this timeline. Okay. The next one is the manage, which is used for managing your policies, your applications, and this is more of a centralized location from which you can define how you want to the different branch sites to work with. So whatever policies you configure get applied on the branch, and this is more about managing what exactly you want the branches to perform. We'll go inside the details of this policy in the next slide, in the future, in the slides in the session today. Okay, and then we have the manage Prisma SD-WAN. Under the Prisma SD-WAN, we have mainly manage. Sorry about that. Yeah, policies and resources are applicable to Prisma SD-WAN. Whatever application, the circuit, the service and DC group, as well as the prefix filters, and then the device access. So access management for your device toolkit can also be configured from here. The next menu is the workflow. The workflow is the most important one, where we can configure the branch sites. We go inside the branch site. It takes you into the configuration menu. Okay, and finally, we also have ION device license management for the virtual IONs here. So ION device, how many licenses you have, how you want to manage your tokens, how many utilize, can be done from this portal. Okay. Let's get back to the slide. Prisma SD-WAN branch sites. So Prisma SD-WAN branch sites are of mainly two types. One is for Prisma SD-WAN sites fall under two categories, either the branch side or the DC side. The branch sides are spokes, which is what we are going to discuss today. In the Prisma SD-WAN branch side, you have operations like path policies, QoS, NAT, and defining your interfaces, your WAN circuits. We have the VPN overlays, which are built between the branch sites and the data center. And this is where the actual branch network, the LAN side of the branch network, connect to. The DC side is more of a transit. It has an active VPN traffic termination, where all the branches terminate the VPN and connect to. Okay, the Prisma SD-WAN branch side, as I mentioned, is typically the branch gateway. It connects to a layer 2 or layer 3 LAN switch, and it connects on the upstream side. It connects to your internet or MPLS or WAN circuit. Prisma SD-WAN solution provides a complete separation of control and data planes. So as I mentioned, all the control plane activities done on the cloud controller, and the data plane activities done on the ION device. So when the ION device connects to the cloud controller, all the config gets pushed and it gets applied on it. If a branch device loses connectivity with the controller, what happens? The ION device will continue to function independently, and the VPNs the Prisma SD-WAN secure fabric VPNs would continue to work for next 72 hours. So in case you have a disruption of your WAN or disruption, or there is an outage where you're not able to connect to the cloud controller, in that instance, you will still have VPNs functioning for next 3 days. The keys will be available there. The ION device supports an active backup HA deployment, where all the internet circuits which are connected to both active and backup device are utilized 100%. The backup device has we have a feature called fail to wire or bypass pair. With this, we would be using both the circuits which are connected to both ION devices at any given point of time, even when there's a hardware failure. The overlay VPNs are of Secure Fabric VPN and Prisma SASE VPN, which is to Prisma Access, as well as standard VPN to third party. Prisma SD-WAN data center or hub. This one, the data center or hub, acts like a transit for all Prisma SD-WAN branch sites for connectivity, especially for services hosted behind the DC, as well as for interconnectivity between the branches. So the VPN from the DC terminates into the branch, and the branch communicates with each other through the transit device. DC, there is no limit on the number of data center we have. We have horizontally, it can be scaled. There's clusters which can be created, and at any given point of time, when a branch connects to a DC or a data center hub site, we have one VPN which is marked as true, while we have a standby VPN which is marked as false. In instance when the VPN goes down with an ION in the DC, immediately the next VPN comes up. So today's session, as I said, is more focused on branch side. The data itself is a big topic. So we will focus on how to build the data set, how to build a branch, Prisma SD-WAN branch side. So in the branch side, we have 3 modes of operation: analytics mode, disable, and control mode. Analytics mode is only applicable to branch. The ION device monitors traffic, collects analytics which are reported, and there's no security or policies are applied. The disable mode is the default mode. And that in disable mode, many functions don't work. It's primarily meant to stage your deployment of your branch side. The control mode is where the device actively participates into the Prisma SD-WAN fabric and starts forwarding the traffic, starts applying the policies and enforcing the security policies if there are anything created. So the devices itself for Prisma SD-WAN comes under 2 form factors. One is the hardware and the software. The hardware, we have Gen 1 and Gen 2. And in the software, we have a virtual ION which can be spinned up into any, most of the hypervisor platforms, so VMware, Microsoft Azure, or the cloud. The device status in the SCM portal can be either unclaimed, claimed, or assigned. So when a device is plugged into the network, it gets connected to the internet, gets connected to the cloud controller. It initially stays in an unclaimed state. So when you get an ION device shipped up, it stays in an unclaimed state. So once you have the device online in the portal in unclaimed state, you can perform the claim operation, and then you can assign it to Prisma SD-WAN branch site. So over here, if you go to the Strata Cloud Manager, you have the workflow, Prisma SD-WAN devices. Under the devices, you have two tabs, claimed and unclaimed. Okay? And you have a bunch of filters available where you can filter according to which status it is, offline or online. And then in the unclaimed devices, you have the devices which are yet to be claimed. So for example, this particular virtual ION is connected, it's running this version of software, it's in unclaimed state. So you can go here and perform the claim operation on this device. So it will prompt you for confirmation that you want to accept this device into your Prisma SD-WAN infrastructure. So once you click on claim the device, it will move this device from unclaimed to claimed state, and it will be appearing unnamed device with the claim status over here. So once you have this device in claim state, you can assign it to a site. So this would apply the site to a Prisma SD-WAN branch site, and it would eventually inherit all the policies and all the configs which you have built on this particular shell, which is the branch site. So in other words, if you remove this ION from this particular branch site, you insert a new ION, it will you basically will have all the configs applied from this config abstraction. So here this particular device, whichever device you replace with, will inherit the config and then start functioning as a branch ION. So in terms of replacement of ION, it's pretty straightforward. You don't need to worry about moving the config from one ION to another ION, one device to another device, backing it up, synchronizing, restoring. So everything is managed by the controller. That's the strength of the centralized cloud controller. Okay. ZTP or zero touch provisioning. So ION controller port, which is for the Gen 1 devices, by default is enabled with DHCP. For the Gen 2 devices, the port 1 is configured with DHCP. So the moment you plug in the box, and if you have a DHCP service through which the device can obtain an IP address automatically, then the device comes online, and it would connect to your the Prisma SD-WAN controller, to the region for which it is assigned to. So the moment it connects, it would be appearing as unclaimed. You just know that in the demo we saw that the device was unclaimed, online, and restricted. And when you claim this device, the KIC certificate gets installed into the box, and then you have the device available under the claimed devices, from which you can assign it to a site and then start deploying, applying all the config and utilizing the ION device. So as far as the user is concerned, the moment the device is shipped to you, the device serial number is allocated to your tenant, and then you can perform these steps. So in scenarios you don't have a DHCP, then you can go to the CLI through the default credentials and configure a static IP, a temporary static IP, so that you can bring the box online and assign it to a site. The interfaces, a very important topic in Prisma SD-WAN. So it's very important to understand various interfaces available and how to use the Strata Cloud Manager portal to see these interfaces, to configure the interfaces, to understand what's happening with these interfaces, to understand what config is missing in the interfaces. So this is kind of a building block of the branch site. It's very important to understand how an interface works. So everything is built on top of this interface. You have a circuit label, you have policies, you have NAT zone, you have security zone. So understanding how the interface works and how to configure this correctly is very important. So under the interfaces, we have physical as well as logical. We have a controller port, which is applicable to Gen 1 devices, and the Gen 2 devices, we don't have the controller port anymore. Internet port, which is your WAN port, WAN or LAN port, aux port. Logical interfaces, we have a loopback interface, virtual interface, the bypass pair interface, a sub interface, PPPoE interface, standard VPN, layer 3 LAN interface, layer 2 switch virtual interface. The interface type port, right? The internet interface type. So interface type can be a port or a bypass pair. So bypass pair, we will see how it works in the next slide. A bypass pair is a pair of ports where one port is connected to the downstream and one port is connected to the upstream. So in a typical HA deployment, you will have the active ion where the internet circuit terminates, and to the port, one of the ports of the bypass pair, and the other port goes down to the downstream device, which is the backup ion, for extending this connectivity from active ion to the backup ion. Okay, the other types are virtual interface and sub interfaces. So primarily in the interface we have internet, private WAN, which is an MPLS interface, the LAN, HA, and L2 switching. The controller port. This port is applicable to the Gen 1 devices. So this is the default out of band port where you can connect the DHCP connection and bring the device online and apply all the configuration. By default, the controller port is DHCP. You can set a static IP. If there is no DHCP enabled access port, DHCP enabled connectivity at the branch, you can access the console and set the static IP. So this is the one minimal configuration which is permitted to be applied from the CLI. Then again, as I mentioned, controller is the source of truth. The moment the device comes online, the controller config takes precedence over what you configure on the CLI. So it's very important to note that whatever you do on the Strata Cloud Manager on the controller is the default config which will be applied on the device. So whatever is done on the CLI is just a temporary troubleshooting, a temporary config we do to connect the device to the controller. So the controller port is used for probing, for app reachability. It can be used for SSH connectivity from the LAN side, SNMP, as well as for NTP. So a source for NTP time sync. And it can be used for HA control also where applicable. If you want, you can use the controller port, or you can use any other port available in the box. Controller port, console port. Console port is also called as an aux port, and it's a dedicated fixed port which gives you, which is the last resort when you don't have connectivity to the controller. You use the console port to connect and see what's going on with the ION device. It's a dedicated fixed port. Is available in all models of ION. And we have a micro USB as well as an RJ45 form factor to connect to. The terminal emulation software to connect to the console port requires the following data rate, data bits, parity, and stop bits. So basically, this is your last resort to go and see what's going on when the device is offline, or for during the initial setup. The interface for internet, which is the main port through which the branch ION connects to the egresses to the WAN to connect to the internet, where the VPNs are built. So this is a untrusted internet boundary. It automatically installs L3 and L4 rules, allowing only inbound IKE TCP port 4500, as well as ESP IP protocol 50. So this kind of this is a port where we restrict all access, inbound access. Okay, and then this is where the VPNs terminate for both secure fabric VPN as well as the standard VPN. It's a NAT boundary where we apply the NAT zone for applying the NAT policies, especially the NAT rule for egress traffic towards the internet, where we need to do a source NAT. And optionally, if you require to do a DNAT or a no NAT, it can be done through the NAT policy. The Prisma SD-WAN Secure Fabric VPN, or the native VPN, or Prisma SD-WAN VPN, these VPNs are formed auto provisioned by the controller. So the moment an SD-WAN branch comes online, and when we have a DC hub available in the tenant, the VPNs are built automatically between the branch and the DC hub. You don't need to go and create these VPNs. And then if there might be situations where you need to connect to an upstream ISP router, where you need to establish BGP and exchange some of the public prefixes which are hosted in your LAN. So this option is available, so where you can set up a BGP routing, BGP peering with your WAN provider, and it supports both sub interface. So in case where you have to set up a VLAN ID, you can, or a no tag, no VLAN, you can set up the primary interface, you can create a sub interface and assign a VLAN tag or a node tag and connect it to the WAN provider's modem or router. And the private WAN circuit. So the private WAN is for MPLS connectivity. So if you have a private network where the branch sites as well as the DC data center is connected to, you can utilize this port and you can configure it. You can select the port from here. So if you look, if you see this this particular port, right, you need you have something called a circuit label, which needs to be configured to map this particular interface with a particular MPLS circuit. Traffic can be forwarded directly on the private underlay, private WAN circuit, or it can be forwarded over the VPN, which is built on top of the private WAN port. So again, this supports a sub interface as well as a main interface. You can configure whichever is required for this port to work. The LAN port is a downstream port used to connect to your LAN switch. Can be used as a layer 3 default gateway for the clients, as well as a transit network. So the difference is you can have the SVIs, the VLAN sub interfaces created on the ION, where you will terminate the gateway for the VLANs on the ION itself, or else it can also function like a transit network, where you have the networks connected behind the layer 3 switch, of course, in the LAN, where you would forward all the traffic towards the LAN gateway, and that would in turn do the downstream routing within the LAN. There is an option for network context, which can be used to define path policies, typically used for guest. So you can define a context called guest and then apply policy specific to guest, where you would like to forward the traffic towards the direct internet instead of sending over standard Prisma SASE VPN or the Secure Fabric VPN. Static routing or BGP routing is supported, and in a small branch, typically a static route is sufficient. But if you need to do a BGP peering with your LAN switch, where you have a layer 3 switch which can act like which can do a BGP peering, you can very well define a BGP peer and learn the routes from the branch. The interface can also act as a DHCP relay for your downstream devices, which need to forward the DHCP, connect to the DHCP, which is hosted in your DC hub. It again supports the sub interface as well as the main interface. So typically for a transit network, you'll have a main interface and you have sub interface for terminating the gateways. There's the gateway for different VLANs in the branch network on the LAN interface of the ION device. So one thing which is very important for a LAN port is the scope. So when we have a knob over here, which can be either global or local. So what is a local scope? So a local scope is something to define that this prefix is local to the branch and doesn't need an external connectivity or doesn't need to be published to the SD-WAN fabric. So there might be a guest VLAN which remains the same across all the branches, where you don't want the traffic from guest VLAN to be going over the fabric. So this is a typical use case for local scope. The global scope publishes the prefixes across the fabric, saying that this particular prefix is connected behind this branch, and anybody wants to connect it would be having reachability when it is defined under the global scope. So the scope is also used for Prisma Access VPNs or Prisma SASE VPNs, where the prefixes are advertised to the Prisma Access through BGP. Okay, so when you have global, it is automatically published and advertised. Okay, the HA interface. The HA interface is primarily for the HA control, for liveliness detection of the peers in the branch side, and the next generation ION device do not have a dedicated controller port. As I mentioned, we need to set up and use for HA as a port type to set up to use this HA control for the high availability to work. The use for HA exchanges the heartbeat between the two ions and also connects to the standby device to the controller, because on a standby device other ports are not operational. and we need to have this HA interface to work. You can use this interface to send management traffic, as mentioned earlier. Use for HA is supported on the following interfaces in HA topology. We have an SVI for HA connectivity, we have a sub interface, and we have a main interface for HA connectivity. Okay, so this is how we define the HA control interface. It's primarily used for HA communication to detect the failure of between active and backup ions in a branch site. So L2 switching is something which got newly added. It is available in ION 3200 in L2 as well as in 1200S. So we have two port types, access or trunk. Typically, an access port is to connect an endpoint, and a trunk port is for connecting multiple VLANs to the downstream switch. The interface tab gives you an option. If you see over here on the right side, you have a plus icon. When you click on it, you can create a VLAN interface, VLAN switch virtual interface. Yeah, so we do support spanning tree on the layer 2 switch. By default, we do MSTP, and then we support STP as well as RSTP. Okay, so I think there are a lot of questions in the chat. Charles?
Yeah, we've got Michael. Again, if I mispronounce names, I apologize. Michael Otram is wondering about the LAN interfaces. Do they support other routing protocols besides BGP and static routes, for example, OSPF? If not, is it planned?
Yeah, we do support, Michael. We do support OSPF from 6.4 onwards. It would be available for you to configure on the LAN side, as well as on the data center side. Cool. So the current version I'm utilizing for this demo is 6.1, and in that we support only the static as well as BGP. So if you need to use OSPF, you need to be on 6.4 and above. Okay, the next one.
Yep. Naresh is wondering where is the options to define local subnets?
So Naresh, for the local subnets, when we set the scope as local, that means that particular subnet is local to the branch. It will never get published outside the branch. So if you set the LAN interface scope as global, that is when it starts advertising the prefix, and if it will be, the other branches will be learning through the DC or that VPN, Secure Fabric VPN or branch-to-branch VPN, that this prefix exists in this branch. So if you set up the scope as local, then it won't be advertised. So I hope this answers your question.
Okay. Yeah, Naresh, if it doesn't just include some more detail, we'll go into more detail if you need. Cecilia is wondering can we configure HA on a virtual bypass pair on the 9200 ION, please?
Yes, you can set up a virtual bypass pair on ION 9200. It should be possible.
There you go. That's a nice direct answer there.
Yeah.
Right.
So I think it's 10 o'clock right now.
Yeah.
We'll take a break, and then we'll continue with the presentation.